Everyone knows about Tesla's production hell with the Model 3, Cybertruck, or Tesla Semi, and other tough challenges the company has faced. This raises a widespread question. For a complex production product like Optimus, as Elon Musk has admitted, will those difficulties also arise in the production of Optimus? And how can Tesla manufacture millions of Optimus units each year? This milestone is approaching quickly, as Elon Musk has confirmed that 2025 will be the year Tesla produces thousands of robots for internal training before officially launching them for sale at the end of the year or early 2026. No company has ever sold robots in large volumes just 3 years after initiating research and development. So can Tesla truly achieve mass production of Optimus? Discover how the Optimus robot is being manufactured at Giga Texas right now. Welcome to evtech. Currently, Tesla has yet to build a dedicated factory for the Optimus robot production line. The approximately 100 Optimus units produced so far are primarily built in a small facility within Giga Texas. They are 100% handcrafted and assembled by Tesla employees. When discussing the production of humanoid robots, Elon Musk once shared this on X. Complexity per unit mass is much higher with humanoid robots, but still I think it ends up costing less than half of a car. Even Elon Musk has admitted that manufacturing Optimus involves a higher level of complexity compared to a car, particularly in terms of complexity per unit mass. You might not know that producing Optimus requires the integration of various scientific and technological fields. First, Tesla's mechanical design must emulate the human body structure, with flexible joints and excellent balance. Proof of this is Optimus's recent ability to walk up and down slopes in a very human-like manner. We've analyzed this capability in detail, and you can watch the video on our channel. Weighing in at 138 pounds, around 62 kilograms, it's clear that Tesla uses materials that are lightweight, durable, and capable of withstanding significant force. Instead of being encased in metal plates, Optimus prioritizes advanced plastics to reduce its weight. In terms of control, the robot requires AI brain to process information from sensors, make decisions, and execute movements with precision and synchronization. Advanced sensors, such as visual, tactile, and motion sensors, play a critical role in enabling the robot to perceive its environment, interact, and move naturally. Tesla already possesses these capabilities through its full self-driving software, so this isn't a major challenge. As you know, Tesla has an incredibly powerful AI and neural network foundation, arguably the best in the world. With Elon Musk's initiatives like Grok, XAI, FSD, Autopilot, Neuralink, and its supercomputers, Tesla's advancements in AI are mind-blowing, making Optimus's brain truly extraordinary. One of Tesla's biggest advantages in potentially mass-producing Optimus next year is its lack of dependency or challenges related to battery supply for the robots. As a leader in electric vehicles, Tesla has no shortage of battery resources. Instead of using conventional 2170 or LFP batteries, Tesla has specifically integrated the 4680 battery into Optimus. This battery offers the highest energy performance and the best cost efficiency Tesla currently has. This creates a significant edge for Tesla over competitors, as the biggest challenges for most companies today are the robot's brain and battery supply. Tesla, however, excels in both areas, setting the stage for large-scale production at an unparalleled level. The biggest challenge lies in the actuators. Once the actuator design is finalized, the focus will shift to manufacturing them. Tesla already knows how to produce batteries and chips. Other components, such as the body and cameras, are relatively simpler. Actuators are the motors that enable movement in the arms, shoulders, and elbows. Currently, if each actuator costs around $1,000, the total cost for actuators alone is $42,000. Adding in other components, the overall cost of Optimus could initially be $50,000 or higher. However, Elon Musk has stated that Tesla could eventually produce Optimus at a cost of $10,000, allowing customers to purchase it for $20,000 once the company scales to producing 1 million units. If Optimus is released for sale in early 2026, we estimate its price could initially be as high as $50,000. We also believe that Tesla can achieve a production capacity of 1 million Optimus robots per year within 3 years from next year and potentially reach 10 million robots in 5 years. If this comes true, we will witness a trajectory of value creation far beyond what people currently imagine. Don't think this is far-fetched. Elon Musk has a way of accomplishing what we once thought impossible. Now, here's some news about Tesla's affordable car, which could be unveiled next year.
Tesla has consistently been a top seller, raking in massive revenue since the launch of the Model 3 and Model Y. However, it's been a while since they introduced a whole new vehicle priced on par with or lower than these models. The company seems to be feeling the pressure as global sales have slightly dipped this year. Meanwhile, profits from Cybertruck likely remain limited and FSD isn't ready for a full-scale robotaxi service. On top of that, sales for Model S and Model X remain disappointingly low. At this point, launching an affordable, highly demanded vehicle might be Tesla's best strategy to shake up the market next year. That's why Model Q, officially confirmed, will be Tesla's 9th vehicle debuting in the first half of next year. Billed as the best compact car next year, it boasts a 284-mile range. Dive deeper into the details of Model Q right now. The new Tesla model is called Model Q in reports, and before it was often called Model 2. It seems they're not official names yet, but we temporarily call it Model Q because the head of consumer relations at Tesla investor, Travis Axelrod, revealed to Deutsche Bank that the car is called Model Q and will be produced on Tesla's existing production line. The launch of Model Q has a great purpose when Tesla had an unimpressive year in 2024 and the number of Model Y and Model 3 inventories still seems to be quite large. This is the reason Tesla continuously launches programs. Promotion during this period, realizing 2025 will be even worse if Tesla doesn't make any moves to attract customers, the company's chosen the best option to launch Model Q, the car that millions of people are interested in and waiting for a long time. According to a report from Deutsche Bank, the Model Q is expected to launch in the first half of 2025, around June, and will be priced at $30,000 in a subsidy-inclusive state, meaning the price of Model Q could be $37,400 if the U.S. electric vehicle tax credit goes away now that Trump is looking to eliminate it. If EV subsidies remain in place and are not canceled by Trump next year, the price of Model Q could eventually drop to $30,000, and it would be the cheapest car for Tesla ever. By comparison, Model 3 currently costs 42 Gs in the US and 35K in Australia after subsidies are applied. Model Q is expected to be 15% smaller and 30% lighter than Model 3 with a length of approximately 157 inches, the same length as a standard Mini. Model 3 is 185 inches long, so cutting it closer to 30 inches would create a fairly compact vehicle. At the start of this year, Model Q was reported by insiders that it would be a compact crossover, but this remains uncertain as Tesla does not yet have a hatchback model in its collection. However, we're sure that Model Q will definitely be the best compact in its price range. Speaking of specs, the Model Q will come in two variants, a single-motor rear-wheel drive with a 53-kilowatt battery pack and a long-range dual-motor all-wheel drive variant expected to include a 75-kilowatt-hour battery, all of which are LFPs. The report states that the car will be able to go up to 500 kilometers or 310 miles on a single charge, but we think that it'll be for the AWD variant, and the price for this variant is also higher. It's also unclear whether that estimate's based on rather generous standards used by Chinese authorities. We think the EPA for the RWD model will be a bit less, perhaps between 230 and 284 miles. Tesla's plan to make about 10,000 of these vehicles per week globally, or about 500,000 a year. As Tesla mentioned in its previous earnings call, this next-gen vehicle will be built using Tesla's existing assembly line with minimal changes, which will allow for smooth and seamless production. Predictable. The company's much-touted unboxing assembly process will be retained for the Cybercab, when and if it goes in production. Model Q will begin in China and then the US, specifically at the Fremont plant in California. It seems unlikely that Model Q will get made in Germany due to the high labor costs. In places where Tesla sells well, a lot of people already have one of the existing models, and some buyers just want something new and different. It has nothing to do with price or size or shape, just new and different. Even some new colors will help increase sales, so Model Q will be always attractive whether it's overly minimalist or not, and importantly, the price will be lower than Model 3.
Before we begin, why do you think Tesla is producing humanoid robots when they are excelling in electric vehicles? The humanoid robot market has never been a lucrative field, with many major companies abandoning their humanoid robot projects midway. Most notably, Boston Dynamics, the world's leading robotics company, has been struggling with its Atlas robot for over a decade, and has even discontinued some of its robots in favor of more feasible versions. The challenges go beyond the difficulty of development and production. The most critical issue is the general public's lack of belief in the utility of humanoid robots. They are often seen as slow, inflexible, cumbersome, and unintelligent. Adding to the criticism is the high price of these robots, which usually exceeds $50,000, making them seem like little more than expensive, clunky metal toys. This is why the humanoid robot market is not an easy arena for Elon Musk to enter as a new player. However, it seems we may have underestimated Elon Musk and Tesla. It's hard to believe the progress they've made with humanoid robots in such a short time. In just 1 year, Tesla has captured the world's attention with Optimus, their humanoid robot. The tasks and actions it performs demonstrate that it is the most reliable humanoid robot to date. If humanoid robots are to integrate into the real world and assist humans with household tasks, it will likely be Tesla Bot leading the way. And the most impressive part? It will be affordable to everyone at a price of $20,000. Let's explore more about Tesla Bot right now. Listen to the CEO of Boston Dynamics share his views on Tesla and the Optimus robot.
The Tesla team are making great progress in 1 year building a couple of machines, from scratch. That's remarkable. They're shining a spotlight on the importance of this technology, which we've been arguing for 30 years.
Yeah, even Tesla's biggest competitors cannot deny the company's astonishing speed. Tesla has achieved in a short time what took Boston Dynamics up to 30 years to accomplish. In the race to develop humanoid robots for household tasks, the Tesla Bot has emerged as a new phenomenon in AI technology. More precisely, Optimus is the product that brings AI into the real world. You can get a recipe for a dish using ChatGPT, but you'll still have to cook it yourself. However, you won't need to do anything at all if you own an Optimus Tesla for $20,000. Exactly 1 year since Tesla launched Optimus Gen 2 last December, throughout 2024, the Tesla Bot has kept fans on the edge of their seats with every demo video Tesla posted. Not only does it perform tasks in factories, but it also takes on many roles as a homemaker. It waters plants, cleans the kitchen, retrieves items from the car trunk, checks and receives packages, serves drinks, and interacts with people in the friendliest manner. For the first time in the world, an electric car company has managed to bring nearly 50 humanoid robots to an event and have them interact with attendees. They danced, gave out gifts, and even disguised themselves as bartenders to serve drinks. Yeah, only Tesla could pull off something like that. Optimus can lift objects weighing up to 11 kilograms, such as battery trays. It can now climb up and down stairs, a feat it couldn't achieve earlier this year. It moves across all terrains, from flat floors to slippery slopes and hilly areas. It has also been equipped with a new generation of hands, showcasing sensors and agility that enable real-time tasks like catching a ball. The most controversial issue about the Tesla Bot this year has been that it is teleoperated rather than fully autonomous. This has raised concerns about its usefulness, since it still requires human assistance instead of functioning independently. However, it seems that most people misunderstand what teleoperation means. Let us explain. Think of it like a human, most easily understood through the example of a child. A child cannot perform tasks without guidance, practice, and training from their parents. Even with training, they cannot execute tasks immediately, but must repeat and practice consistently over time to perform well. Optimus is no different. It needs to gather data before it can perform tasks autonomously. If the robot is trained and educated, it can quickly perform a wide variety of tasks. This is the key reason Tesla is achieving increasingly rapid progress. Elon Musk once said that Optimus is the humanoid robot with the best brain in the world, enabling it to understand humans as humans understand each other. That's why Elon Musk believes that even without direct commands, Optimus can learn habits and autonomously perform tasks. To put it simply, imagine coming home after a long day at work. As you sit down on the sofa, Optimus will automatically pour you a glass of water or bring you a beer without you having to ask. As Elon Musk said,
yeah, you'll be able to customize the personality, customize the voice, and really kind of the robot will kind of get to know you as well and know your preferences. You won't even have to say things because it'll just kind of understand you.
It's no coincidence that millions of people want to own an Optimus. as we are increasingly convinced by the capabilities of this robot.
As we know, ChatGPT took years of research, and when it entered the market, the need for information searches on Google started to decline. Similarly, in the field of electric vehicles, this seems to be about to happen, something that even Elon might be worried about. It's Toyota's 1,000-mile solid-state battery. It took years of research, and the Japanese car manufacturer has been pretty persistent with it because they think this battery technology will help them reclaim the market position they lost to Tesla and other brands. A 1,000-mile range kind of seems like a dream. We know you might have doubts too. We did as well. But ultimately, this could be a nightmare for Tesla in the coming years. So, how intense will the race for battery tech become? And why might Elon be a bit concerned about Toyota's new solid-state battery? In fact, it's not just our personal opinion. Many people agree that solid states are currently the most promising breakthrough technology, or more accurately, the one with the greatest potential to surpass traditional lithium batteries. The advantages of solid states are already significantly stronger than lithium-ion, but that's not the only benefit. In addition to energy density, Toyota's solid-state batteries have numerous advantages in terms of charging speed, safety, and lifespan, fundamental factors that can make a battery a game-changer. Many assert that this type of battery is truly a Tesla 4680 killer. Is that true? Let's start with the concept of solid-state batteries, because we believe that not everyone is familiar with them, especially Toyota's solid-states. Essentially, solid-state battery is a lithium-based battery, kind of like those used in today's electric and hybrid vehicles. But the big difference is solid-states use a fully solid electrolyte, rather than a liquid or gel electrolyte found in conventional lithium-ion batteries. In short, all you need to know is that the electrolyte is a component in the middle of the battery. Think of it like a sandwich with filling in the middle. One has sauce inside and the other has meat as the filling. One's liquid form, the other solid. You should also know a fact: liquid or gel electrolytes offer almost no advantage over a battery cell with a solid electrolyte. If there's any advantage, it's simply that the liquid are commonly used because the industry is currently more familiar with and better developed around them. However, just because we're familiar with it doesn't mean it's better. It's just that the innovations are always an improvement over the old. That's why more manufacturers are choosing solid electrolytes as a replacement, leading to the rise of solid-state batteries. Toyota's become a major manufacturer, daring enough to propose the most ambitious specs for its solid-state batteries, nearly 1,000 miles. The fact is that Toyota actually introduced a solid-state with a range of over 1,000 kilometers or 621 miles back in 2010. Toyota then increased this to 1,200 kilometers with the next generation, and with the final premium version, they're confident their solid-state can enable EVs to get to 1,500 kilometers or 1,000 miles on one charge. That is nearly triple the range of most EVs out there right now. A 1,000-mile range means that this battery could have an incredibly high energy density compared to conventional lithium cells that use liquid electrolytes. Example: Tesla's 4680s have a density of around 272 watt-hours a kilo, and with a 123 kilowatt battery pack, they provide the Cybertruck at least 325 miles of range, so it could get up to 400 miles in a lighter Model Y. Therefore, Toyota's solid-state battery has an energy density of around 600 watt-hours a kilo, meaning it can deliver more than twice the energy, creating a lighter and more compact battery. And that's a breakthrough for electric vehicles, helping increase range and cut vehicle weight, exactly what Elon's been after for several years now. To replace the liquid electrolyte and separator found in traditional lithium batteries, solid electrolytes use solid oxides or sulfides as conductives. Solid electrolytes are denser than liquid or gel electrolytes, allowing solid states to give out more energy for the same weight or volume. Another benefit of Toyota's higher energy density battery is that it'll cut the need to charge your vehicle frequently, saving time and money with lesser charging sessions. With a higher energy density of solid-state batteries, Toyota can up the power and performance of the vehicle, and that's because these types of batteries give higher voltage and current. As a result, acceleration, handling, and speed are enhanced. Just imagine this type of battery combined with Tesla's 48-volt architecture. It is truly exciting.
What do you think about Tesla producing multiple versions of its humanoid robot Optimus and selling them at different price points? Of course, there will be clear distinctions between the versions. If the current Optimus Gen 2 is already astonishing, the next version, Gen 3, will be even more mind-blowing. It features upgraded hands, a new design, improved operational specs, everything to make Optimus Gen 3 more flexible and better at handling tasks than the current version. Let's explore the exciting innovations in Optimus Gen 3. It's clear that the Optimus Gen 2, which already impressed us with its dexterity in the tasks Tesla showcased, set a high standard. However, Optimus Gen 3 will boast hands with double the degrees of freedom. This upgrade not only enhances functionality, but also redefines what a humanoid robot can achieve. From simple tasks to highly precise operations, Tesla Bot's new hands clearly offer a significant advantage. For example, in a demo video, it catches a ball with pinpoint accuracy, something only the new hands could accomplish. Additionally, the integration of advanced sensors and improved water resistance means that Gen 3 can handle twice the number of tasks Gen 2 might struggle with. Whether it's cooking, washing dishes, or tackling water-related tasks, Gen 3 holds a distinct edge. In addition to its revolutionary hands, Tesla Bot Gen 3 may be equipped with Tesla's most advanced AI-5 technology. Currently, Tesla utilizes hardware 3 or 4 for Gen 2. So if this upgrade happens, Optimus Gen 3 will have a brain on a whole new level. Imagine asking Tesla Bot Gen 2 to fold clothes. It simply folds them. But Gen 3 could sort them by color and material and then neatly organize them in your wardrobe. That's the difference. Tesla has also perfected Optimus's ability to navigate rough terrain, and Gen 3 is set to showcase even greater advancements. With lighter materials and more powerful actuators, Gen 3 will not only move more gracefully, but will also walk with a gait that looks less like Joe Biden's. Its movement speed will also surpass that of Gen 2. As Elon Musk hinted, Optimus Gen 3 might feature a distinctive design. While we don't know the specifics yet, we can expect a sleeker appearance, possibly incorporating elements like a display screen on Optimus's face or customizable body colors. Yeah, something like that. With a price expected to exceed the $20,000 to $30,000 range of Gen 2, Optimus Gen 3 clearly targets a more premium market segment, potentially ranging from $50,000 to $80,000. What do you think about this price point? Now let's talk about the new battery technologies that Tesla will likely use for its electric vehicles.
CATL is the world's largest battery supplier, and they are striving to create the next era for EVs, or more precisely, for Tesla EVs. They've announced a battery pack capable of going 1.25 million miles. This figure could even be higher, because CATL states the battery pack does not even fail after that range, meaning its total range could reach 1.3 or even 1.4 million miles. Musk is collaborating very well with CATL's LFP battery, and there's no doubt that this 1.3 million mile battery pack will be the next battery technology to be installed on Tesla's EVs. Over the last 10 years, CATL's consistently strived to create breakthroughs in battery technology as the electric vehicle industry gains customer trust. They previously introduced super fast charging battery packs to optimize charging speed, taking only 10 to 15 minutes to fully charge. This time, CATL aims to dispel any worries about an EV battery lifespan, a common concern among many customers. You know, replacing an EV battery pack is not cheap, so what if your electric vehicle's battery needed a replacement only after more than 16 years? Wow! The largest EV battery manufacturer just released a new video claiming their long service life battery pack can last up to 16 years or 1.24 million miles, equivalent to 2 million kilometers. That's hard to believe, considering that when we previously looked into CATL's battery lifespan, most findings indicated that their battery packs perform well for about 4 years and degrade or need replacement after 5. Meaning those battery packs have a lifespan of under 1 million miles. However, CATL seems to have dismissed these concerns and is very confident in their latest battery technology. Regarding Tesla's EVs, Elon once mentioned on X that the batteries currently in Tesla's Model 3 could last around 1,500 charge cycles or 300,000 to 500,000 miles. So, what if this Model 3 were equipped with a battery pack capable of running 1.3 million miles? Nearly 1.3 million miles is an incredibly long distance. Assuming a Tesla Model Y has a range of about 300 miles, that means Elon's SUV would still be running smoothly even after 4,000 full charge and discharge cycles. We believe 5,000 cycles might even be doable with this latest battery technology, as CATL has not stated that the battery will fail after reaching 1.24 million miles. Instead, they guarantee that you'll get 1.24 million miles from the battery, which implies that after reaching this range, the battery might degrade but will still be usable for many more cycles. In the case of a Tesla EV with a larger range, such as 380 to 400 miles of charge, the number of cycles for the battery is going to be lower. However, the key point is that your battery will outlast almost any vehicle, given that looking at the current electric vehicle market, very few drivers can reach 1.2 million miles or 2 million kilometers. We haven't heard of any battery or EV capable of running up to 2 million kilometers without needing major repairs. Comment below if you think we missed something. Additionally, considering that an average internal combustion engine lasts only about 150,000 miles compared to Cattle's nearly 1.3 million miles, which would you choose? We think there's definitely a strong appeal for EVs equipped with this battery technology. In reality, a battery capable of running nearly 1.3 million miles is likely made from standard lithium cells, possibly lithium iron phosphate, as this type of battery is known for its durability and safety. Although Cattle has not provided specific details until the official release of this battery technology, LFP is currently the most popular battery technology. However, we should focus more on how Cattle's managed to make these battery packs last for millions of miles. The Chinese battery manufacturer has summarized several chemical technologies that contribute to extending the lifespan of lithium-ion batteries in their effort to achieve 1.3 million miles. First is its low lithium consumption technology, which stabilizes the surface and structure of anode materials. In addition, a self-passivating film has been adapted for the cathode electrode, something it calls FIC coating technology. Third is a bionic self-repairing electrolyte, which can reverse some of the degradation within the solid electrolyte interphase SEI film. The electrolyte also has various layers to help minimize degradation. Moving outside the battery cells to the pack level, Cattle also enhanced longevity with some mechanical solutions. According to Cattle, the electrodes inside thicken as batteries get used, leading to increased swelling stress. The company developed a flexible expanding force management system to adaptively manage the cell expansion force and minimize the pressure. Cattle's marketing video does not provide detailed explanations about the outstanding results of their long service life battery. The company's website specifies that the warranty period for passenger EV batteries is 8 years or approximately 500,000 miles. On top of that, the newly launched Cattle Tianxing battery for commercial applications also has an 8-year warranty, equivalent to 800,000 kilometers. Therefore, we can assume that the 16-year or 1.24 million miles figure is a potential output rather than a guaranteed lifespan. At least some Cattle batteries might reach such a level under relatively good conditions. Of course, nothing on Earth is perfect, and any battery technology in the world is going to have its drawbacks. For the new 1.3 million mile battery technology, Cattle's chairman Zhang has stated that the million-mile battery will only be about 10% more expensive than current EV batteries. Looking at Cattle's current LFP battery packs that cost between $56 and $60 a kilowatt hour, a 10% increase would mean the new 1.3 million mile battery pack would cost around $70 a kilowatt hour. If prices fluctuate, it might go up to $80 per kilowatt hour. This cost still remains relatively reasonable and would not be a significant hurdle for Tesla. As we know, Elon pays particular attention to battery costs. Tesla is striving to reduce battery costs to enhance competitiveness. Specifically, in an interview with Bloomberg, Cattle's chairman Zhang revealed that Cattle and Tesla have prioritized the development of cobalt-free batteries, a move that could further reduce production costs for Tesla-branded vehicles, as cobalt is a pretty expensive metal. Elon talks about cost all day long, and I told him to be assured that I'd have solutions, Zhang said about Musk in an interview. The reality is that even if the cost goes up by 10%, it's not alarming as it might seem, because lithium-ion battery prices have been going down rapidly over time. According to Bloomberg New Energy Finance, battery prices dropped by 13% a kilowatt hour from 2018 to 19. By early 2024, lithium battery prices are still going down, and it's likely Cattle will eventually achieve that optimal pricing for this groundbreaking battery technology. Thanks for watching our video. If you found the content helpful and want to explore more exciting info about Tesla EVs, don't forget to hit the like button and share this video. Also, make sure you subscribe to our channel and turn on notifications so you never miss out on our latest videos. We appreciate your support and look forward to seeing you in the next video.